Hello guys, welcome back to your channel Learning Point. Today we are learning differentiation composite functions. Now when we talk about composite function, the very first thing that we should know is what is the meaning of the word composite function. So we say that any function inside another function is called as composite function, or we can say function of a function is a composite function. Like for example, if you have log x, then this kind of a function is called as a basic function. But instead of x, if I have log of 5x minus 1, so there is a function 5x minus 1 inside the logarithmic function. Therefore, together log 5x minus 1 is called as a composite function. Or in case if I have e raised to x, then this is a basic function which is just an exponential function. But instead of e raised to x, if I have e raised to 7x square minus 2x plus 1, then this over here is called as a composite function. So now in this lecture we have to study how we have to find out the derivatives of this kind of function. Always remember a simple thing. I'll give you a note. Anything other than x inside a function is considered as fx. So now what does that mean? First of all, we'll see all the formulas and then we'll see the application of this particular note. So let us go to our formulas. Function and the derivative. Okay. So the very first formula that we have is y is equal to fx raised to n. This fx raised to n is similar to x raised to n. So what is the derivative of x raised to n? It is n into x to the power n minus 1. So when we come across fx raised to n, I get dy by dx is equal to n into fx raised to n minus 1, and again we have to multiply this with derivative of fx. Now you will think, ki why did we not do it over here? Obviously we could have done it over here also, but if we multiply this with derivative of x, which is the base value over here, as you can see I am multiplying this with the derivative of the base fx. So here if I multiply with the base, which is x, then what is derivative of x? It is 1. So I will get n into x raised to n minus 1 multiplying by 1. So multiplying by 1 does not give a big difference. Therefore, what we do is we just ignore this particular part and we just keep our formula as n into x raised to n minus 1. Okay. So that was the first formula, which is fx raised to n into fx raised to n minus 1 multiplied by derivative of fx. Obviously, we'll see an example for this also. Suppose if I have y is equal to 3x square plus 2x plus 1 to the power 4, we have to say differentiate with respect to x, as you all know. So derivative of y is dy by dx. As per our formula, if I compare, the value of n is 4. So this is 4 into bracket 3x square plus 2x plus 1 to the power 4 minus 1, that is 3, multiplied by derivative of fx, which is derivative of 3x square plus 2x plus 1. Now over here, this 4 into 3x square plus 2x plus 1, the whole cube, will be taken down as it is. And when I multiply with the derivative of 3x square, it is 3 into 2x, which is 6x. And derivative of 2x is just 2 into 1, that is 2. Derivative of 1 is 0, so we can ignore that. So our final answer comes out to be equal to 4 into 3x square plus 2x plus 1, the whole cube, and over here the derivative of this, which is 3x square plus 2x, which is 6x plus 2. Okay, so that is about the application of your first formula. Same way, when I want to use or apply the second formula, so let us see what is the second formula over here. Y is equal to root fx. Yes, you got it right. When we take root x, then derivative of root x is 1 upon 2 root x. So instead of x, I have fx. So same way as we did in the previous case, it will be 1 upon 2 root fx into derivative of fx. Once again, let us see an example for this also. Suppose if I have y is equal to under root of 7x minus 1. So in this case, again I will say differentiate with respect to x. So derivative of y is dy by dx, which is equal to 1 upon 2 root 7x minus 1 multiplied by derivative of 7x minus 1. Now this 1 upon 2 root 7x minus 1 is outside the derivative sign, so we leave it as it is. And derivative of 7x. Derivative of x is 1 and 7 is the coefficient, so it will be 7 into 1, which is 7. Derivative of minus 1. 1 is a constant, so derivative of that is 0. So that is your final answer, 7 upon 2 root 7x minus 1. I hope you guys are able to get it. It's a very easy thing, guys. Number 3. Y is equal to log of fx. What is derivative of log of fx? It is similar to log of x. Derivative of log x was 1 upon x. So derivative of log fx will be 1 upon fx into derivative of fx. Chalo, let us take one more example for this. Okay. So if I have y is equal to log of 9 raised to x minus 1. So in such a case, derivative of this 1 upon 9 raised to x minus 1 multiplied by derivative of 9 raised to x minus 1. So the outer element 1 upon 9 raised to x minus 1, it will be as it is, multiplied by derivative of 9 raised to x, which is of the form of a raised to x. What is derivative of a raised to x? It is a raised to x into log a. So this is 9 raised to x into log of a, that is log of 9, and minus 1. So derivative of 1 is 0. So we get just 9 raised to x log 9. Simple. Number 5. The fourth one, y is equal to a raised to x. What is derivative of a raised to x? It is a raised to x into log a. So if I have a raised to fx, so the answer for this will be a raised to fx into log a multiplied by derivative of fx, like we did in the previous case. Let me take one more example over here. Y is equal to 7 raised to 5x plus 2x square. So I will get dy by dx is equal to 7 raised to 5x plus 2x square multiplied by log 2 multiplied by derivative of 5x plus 2x square. Now this 7 to the power 5x plus 2x square, it will be as it is. Log 2 will be as it is. But what is derivative of 5x? It is 5. Derivative of x square is 2x. So twice of 2x is just 4x. So that gives you answer. And the last one, e raised to fx. What is derivative of e raised to x, guys? It is e raised to x. So what should be for e raised to fx? It should be again e raised to fx. But again we have to multiply this with derivative of fx like we did in all the previous examples. So these are the basic formulas guys which we will be using when we are solving our exercise or solving our examples. So now let us understand how we apply this in a few more questions, and we will also take such questions which are combination of the rules of differentiation which we have seen in our previous lectures, previous videos. Guys, I would suggest if you have not yet studied the rules of differentiation or the basic formulas of differentiation, I am providing you a link in the description. It would be good for you if you go and just have a look at those formulas, just try to understand those examples, that basic sums that I have given over there, and then if you come and refer this, it would be very easy for you to understand and apply the concepts and formulas over here. Okay, so I'll give you the link, just check it out. I'll continue with the further examples for this. Suppose if I have y is equal to e raised to 9x square minus 5x plus 4x cube plus 2 raised to 1 by 4. So what do we do in this case? If I observe the first example that I have, it is of the form of e raised to x. What was the formula for e raised to x? It was e raised to fx into derivative of fx. So I have to say over here, differentiate with respect to x. So derivative of y dy by dx. So it is e raised to 9x square minus 5x multiplied by derivative of the function which is 9x square minus 5x. As I had told you in the very beginning, see, anything other than x inside the function is considered as fx. So here I consider this entire function as fx. So if I consider this entire function fx, so it is just like as my formula e raised to fx into derivative of fx. Same way, for the second case or the second term, I have to consider this term as my fx, and it is fx raised to 1 by 4, which is same as fx raised to n. And what is the formula for fx raised to n? You got it right. It is n into fx to the power n minus 1 multiplied by derivative of fx. So let us see how we get this applied over here in this sum. Plus n is 1 by 4, so it is 4x cube plus 2 whole power 1 by 4 minus 1 minus 3 by 4 into derivative of 4x cube plus 2. So this e raised to 9x square minus 5x remains as it is. Derivative of 9x square, so that is 9 into 2x minus derivative of 5x, which is just 5, plus this 1 by 4 into 4x cube plus 2 raised to minus 3 by 4 multiplied by derivative of 4x cube. So what is 4x cube का derivative? 4 into derivative of x cube, that is 4 into 3x square, plus derivative of constant 2 is 0. So I will just get 4 into 3x square. So finally, what I can do over here is I can cancel off these both 4 values over here. So the answer that I get is e raised to 9x square minus 5x, 9 into 2, 18x minus 5, plus 4x cube plus 2 raised to minus 3 by 4 multiplied by 3x square. So this is the way we will be applying our formulas for the composite function. Okay guys, one more example I will take. Example 2, y is equal to log of 9x plus 1 multiplied by 5 raised to 7x. Okay, so let us see what we can do in this sum. If you observe very carefully, I can understand this over here is a logarithmic function and this over here is an exponential function. Because we are having a product of two terms, it means that we have to apply the multiplication rule in order to solve this particular sum. So now, what exactly is the multiplication rule? If I have y is equal to u into v, I say that dy by dx is v du by dx plus u dv by dx. So in this case, what we can do is I consider the first term as u and the second term as v. We have to write over here differentiate with respect to x. So derivative of y is dy by dx. V into derivative of u, 5 raised to 7x into derivative of log of 9x plus 1 plus log 9x plus 1 multiplied by derivative of 5 raised to 7x. Once again I am repeating guys, anything other than x inside a function is considered as fx. So over here 9x minus 1 will be taken as fx, and in the second part 7x will be taken as fx. So when I substitute my first formula, that is log of 9x minus 1 representing log of fx, according to which I can say 5 raised to 7x into 1 upon 9x plus 1 into derivative of 9x plus 1 plus log 9x plus 1 into 5 raised to 7x into log 5 into derivative of 7x log fx, and this is a raised to fx. Derivative of a raised to fx is a raised to fx log a multiplied by derivative of fx. So I can write 5 raised to 7x upon 9x plus 1. What is derivative of 9x? 9 into 1, that is 9. Derivative of 1 is 0, so I get 9 plus log of 9x plus 1 multiplied by 5 raised to 7x into log 5 into 7. So that completes your answer for this particular sum. I hope you have understood how we have to apply this particular composite functions rule over here. In the next lecture, in the next video, I'll continue and I'll take up some more textual sums of the textbook of prescribed by the HSC board, and we'll learn how to solve those sums. Till then, I wish you just by heart all these formulas and be ready for the next lecture. Thank you everybody guys. Take care.